Okay, this is a handout that's titled Section 3.6 Classwork, but it could easily be included in your overall notes packet. In fact, if I'm giving you a notes, like for the whole chapter, a notes packet, it very well could be included in that with the rest of the other normal notes. So also with this handout, probably in class, it is going to be, not your typical procedure for going through notes. We're probably going to have you guys try this and kind of go through it like an assignment and then sort of go over it afterward. But there's definitely some things on here that like you want to think of as notes or things that actually need to be sort of learned a little bit. But anyway, so if you want to try this, if you have the paperwork for this, if you have the actual handout, what you might want to do is try all of this, filling out the tables, seeing what these graphs look like before going through the video. But here's what you'd be doing. On this handout, we just have really a bunch of equations with x and y, two variable equations. And we're going to be looking to fill out tables, or fill out a table for each equation, and then take that table and transfer that information to make a sketch of a graph for that equation. So again, we're looking to sketch a graph of this equation by making a table of a small number of solutions. Okay, so all you'd be doing is taking these given x values, all these separate different values for x, plugging each one in, just like you may have done before in your life in a previous math class, filling out an XY table. Same thing if you've ever done this before. You're taking like all these separate x values one at a time, letting x equal each one, and then seeing what y would have to equal to go with it. So for example, if we plugged in -3 for x, and so we'd have to square it and then add 1. And remember, if to properly square a negative number, so to square -3, you're going to get +9. And then when you add 1 to that, the final overall value for y is going to be 10. So you do -3 squared plus 1 to get +10. So keep that in mind. Like for example, if you're just plugging this into a calculator, if you plug in -3 squared plus 1 and you don't put parentheses around the -3, then your calculator is not going to give you the correct answer. You're not plugging it in correctly. So keep that in mind as you look to fill out the rest of the table, and then take, say, that solution, which would be -3, 10, and that's going to end up being a point over here on the graph, along with all of these other solutions that become points over here. And then you got to try to connect the dots, to kind of see what the graph of this kind of equation might look like, or this kind of equation based on these 7 points, these 7 solutions that you can throw onto the graph and try to connect the dots. This one with the absolute value. But that's all I'll say for now before giving you the opportunity to pause the video and try this yourself. So again, last chance to pause before we kind of just run through the answers, okay? Alright, so if you've attempted this on your own, plugging in all these separate values for x, we get -3 comma 10, which, let's ungroup those. So this would be our -3 comma 10, this would be our -2 comma 5, this would be -2 comma, what did I say? This would be our -1 comma 2, this would be 0 comma 1, and so on and so forth, okay? And again, these are just 7 examples of solutions, This table doesn't even come close to containing all the solutions, because how many total solutions can there be for this equation? Technically, there's an infinite number of solutions. Like, these are some very typical x values that you often see in a table, but I can plug in whatever x I want, right? So if we ended up talking about, what's the overall domain and range of this relation, which, is, by the way, it's also a function. But if I wanted to know the domain and range, you wouldn't just go by what you randomly put in a table, because there's an endless number of values in our domain. Technically, it's any number you want, so all numbers are in our domain. But anyway, all we're looking to do mainly on this handout is get an idea of like, oh, so this is what the graph will look like, when you try to take these 7 dots. And keep this in mind as a general rule of thumb. The more points you put in your table and on your graph, the more some weird, unknown, unfamiliar graph, the more it's going to take shape, right? Like, can you imagine if you only had this point and this point and this point to go by? And even if you had this point as well, you wouldn't know what this graph is going to ultimately look like and do. So the more points we have, the better. But it's going to end up being this U-type shape. This U shape. This next one, these are the values that you should end up getting by plugging in all these different numbers for x to see what that would make y equal. And when you throw all of those onto the xy plane, you basically just get a line, So we connect the dots because, I don't know if I quite said this about number 1, but we connect the dots, to kind of show all of the infinite number of solutions. It's not just like this point and this point and this point and this point. There's an infinite number of packed points, right? Which include, maybe like in this table I could have put 1.5, and plugging in 1.5 we would have got -2.5, like right there. Like, that's another point on this graph, as well as an infinite number. It's like point. This table we can only put so many in an actual table that we write down, but there's an infinite number, which is why we end up connecting the dots, because we're basically drawing an infinite number of dots. This one with the absolute value, hopefully you knew that if you tried this beforehand, that this says y is going to always equal the absolute value of x minus 3. So the absolute value of -3 is 3, and then when you minus 3, you get 0. The absolute value of negative 2 is 2, and then when you subtract 3, y ends up equaling that. And then to skip down here, the absolute value of positive 3 is just going to be positive 3. The absolute value of 2 is just going to be 2. So that's why we get these values, and when you throw them onto the plane and then look to connect the dots, this ends up taking the shape of a V. All right? Now we get to what I believe is the back side of the handout, okay? Okay, so this is probably the biggest reason why I would consider this not just a little in-class assignment, but also kind of a notes handout. All of these exact equations on the back of this paper, starting with this one, these are literally going to be 6 or 7, let's see, 1, 2, 3, 4, 5, 6. So there's 6 of these, and I believe, I can't really spoil it too much right now, but maybe you'll see once we do the sample test. I think there's going to be a bonus graph, but anyway, to cut to the chase here, there's going to be 6 or 7, 6 plus a bonus, of these exact equations that I need you to sketch a graph for. Now the idea is, so for this one, yeah, technically you can make a table, right, and use these, handful of points, -3, -3, -2, -2, -1, -1, to sketch your graph. But, even before I continue on with the rest of these, I'm going to tell you kind of what the idea is. The idea is not for you to need a table to kind of literally, not literally plug, but plug all of these different ones to kind of fill out this table to make your graph, just to know the graph. So the idea is heading into the eventual, chapter test, to just know that this equation is a line. It makes an uphill line that just goes through the origin, y equals x, which the table will verify that if you want to, like 0, 0, put a dot right there, and 1, 1. But the idea is just to memorize these graphs. So again, without even caring too much at first about how the table ends up filling out, y equals -x ends up being a downhill line through the origin. And of course, the plugging in all these different x values to get the corresponding y values, that just verifies it with all these points that make up this line, along with an infinite number of others. Y equals x to the second power, compare this to just y equals x. Y equals x was a line, but y equals x to the second power, y equals x squared, that ends up being a U shape. Kind of like number 1, because it had an x squared. See, this is one of these concepts that maybe you'll start to learn with this little, this assignment, this activity. That, y equals x squared, it was a U shape. Maybe they're all like that, and it's like a family of U-shaped graphs, anything with like y equals x squared, which, yeah, basically. So try to remember, starting kind of now-ish, that y equals x squared is a U-shaped graph that kind of sits on the origin like this. And when it comes to the eventual exam, I'm not going to be too strict about, is it passing through all of these exact points? I think as long as you remember that it's a U shape that sits on the origin, I'll be happy. It doesn't need to be too pretty. Y equals x to the third power. Again, when it comes to the test, you won't need, to fill out a table, I mean, you can if you want to. That's a great fallback plan, isn't it? To just sketch out or write out a little quick table and then just make these points. But hopefully you can just remember that y equals x to the third power, okay, makes this kind of a graph where it kind of comes up and does like a little twist, like it starts to do a U-turn, but then psych, just keeps going up, okay? The next, and again, you don't need to make it super perfect as long as you know, like you could just kind of go like this. Well, that's awful. It's tough with a mouse. I mean, oh jeez. Forget it. But again, you don't need to have it passing through, you know, these perfect points like -1, -1, and -2, -8, right? As long as you remember that it kind of does like this double turn. And then this one, hey, y equals the absolute value of x. We did this on one of these on the front page. And just like that one, this one ends up being a V graph. So you need to try to remember that absolute value. Value starts with what letter? A V. Absolute value graphs. It's a whole family of functions of, you know, represented by equations and stuff. But the absolute value family of functions, they all make V graphs. And this one, just your basic y equals the absolute value of x equation. Remember, this exact one is going to be on your eventual chapter test. And it's this sketch of a V sitting right on the origin. This one is the square root function. Y equals the square root of x. This one's kind of interesting because if you already tried this on your own, if you ask your calculator or just think inside your own head, what is the absolute value of -3, you know? I mean, hopefully you kind of have at least some experience with absolute value. Absolute value of something is what number times itself will equal that number. So if you're doing like the absolute value of -3, you're thinking like what number times itself would be -3. And what? You know, that's why when you throw that into your calculator, it gives you maybe some kind of error or something. Domain error, I don't know. Some kind of error. Because you can't, there is no answer to the square root of -3. In fact, there's no answer to the square root of any negative number. You can do the square root of 0 and the square root of 1. Can you do the square root of 2? You know, let's hold on. Maybe I'll backtrack a little bit first. Remember, what's the square root of 0? Like, what number times itself equals 0? 0. What number times itself equals 1? 1. Skipping down here, what number times itself equals 4? 2. The square root of 2, what number times itself equals 2? Well, if you're thinking that, I mean, well, hopefully you're thinking that, well, there probably is such a number, but it's not a nice number. It's kind of a number you'd have to approximate. So yeah, there is an answer, you know, to the square root of 2. It's just this like never-ending, well, it's irrational, right? It's an irrational number, which we've probably talked about, you know, a number of weeks ago. So yeah, there is a square root of 2. It's just something that needs approximated here. And then what's the square root of 3? It's about 1.7. You know, 1.7-ish times itself, you know, would equal 3. And so what's this graph going to look like? Well, kind of like this. It starts out of thin air here at 0, 0, and then curves up and sharply to the right. But it's going to keep going up forever as it goes to the right forever. And literally, again, because of this kind of situation, there literally is no graph to the left of the y-axis, because it's just, you can't plug in any of these. There's no point at all. There's no points at all. So that's why this graph starts out of thin air and then goes off to the right. For all of these x values, there's going to be dots somewhere. But yeah, so again, just a quick reminder, you know, this exact equation, which hopefully you graph something very, very, very close to this graph on the test. This one making a V, you know, this one kind of doing this up and then like a little double turn, and this is a U shape, and then these are kind of a couple of lines. And you know, you can do the tables on the test if you need to, but the idea is that you just start to memorize these 6 graphs. This one, this one, this one, this one, this one, and this one.